What is the internet? In today's video, we will see what the internet really is. I will put its definition in four main concepts. First is a sequence of connected devices. The second is ISPs or internet service providers. The third is protocols. The fourth is applications. Let's start with a sequence of connected devices. Consider an analogy of a city. Let's consider this as our city with houses, roads, traffic signs, and intersections. Yep, take the houses as end systems or hosts, roads as communication links, traffic signs and intersections as routers and switches. So when we want to send something from house A to house D, the package will take the load. Then when it reaches at an intersection, the traffic signs will guide it to its destination all the way from house A to house D to avoid taking the wrong or unnecessary paths. Let's look at this in the internet reality. Suppose you have a phone, a tablet, or a computer in front of you right now, which are also known as hosts or end systems. Other examples of hosts are servers, printers, smart cars, smartwatches, etc. For the time you hit that address of youtube.com and hit enter, your host segmented that request into packets. Then it took a path, which is a set of routers, switches, and communication links, where your packet will pass all the way to its destination server, which holds the web pages and the content that you were seeking. Keep in mind that the destination devices are always hosts or end systems, whatever you can call that. So let's continue. The packet switches, which are routers or layer 3 switches, which operate on the network core. We'll see about the layers in later courses. Don't worry. So there's routers or layer 3 switches and linked layer switches perform the work like one of the traffic signs that we have seen, means that they are there to tell the packet the real path to take towards its destination, and this is called packet forwarding, which is when a router forwards the packet to the next hop. If you are new to this term, the next hop is the next inbound interface of the next router. We will see these two in the upcoming chapters. Make sure you hit that subscribe button so you will never miss that. This red mark is the next hop. Routers also forward a packet by first reading the destination IP address in the packet's header, then learning the routing tables for which path the packet will take using routing protocols. For example, some use the shortest path, like OSPF. The additional thing here is that a packet has two main parts, which is the header and the payload. Now, consider this huge framework of these devices that we've talked about all over the world, repeating the same process again, and again. So, that's the first way to define the internet. So now let's jump on the ISPs or internet service providers. Those are the companies that link our end systems to the global internet. So they play a very, very big role in the existence of the internet. Let's see how it happens. First, you connect your phone via cellular data to the local ISP. We will cover more about cellular data in the upcoming lessons. Don't worry about that. The local ISP, which also called Tier 3 ISP, you are connected to via your phone through a nearby cell tower or through your home internet or office internet. Then that local ISP also is connected with other ISPs in the same region or by a regional ISP, which is also called Tier 2 ISP. Finally, all the regional ISPs too are connected by the global backbone, which is known as Tier 1 ISPs. Those tier 1 ISPs are connected to each other among themselves. Nothing is above them. We will see some deeper details on ISPs in other courses as well. That's how ISPs help the internet to be as we know it today. You can't say the internet and forget about protocols, because after physical connectivity, the internet is all about protocols. We will see some of them in some detail very soon. Keep in mind, this is a standard that internet applications and devices use to communicate with each other and also be able to exchange information. Today, the most important protocols of the internet are TCP, or Transmission Control Protocol, and Internet Protocol. Finally, there are applications. The internet is home to applications. Applications that do almost everything in our daily lives. Those are messaging applications, music streaming applications, television streaming applications, multiplayer games, and so on. The applications are said to be distributed applications since they involve multiple end systems that exchange data with each other, as we've seen earlier. Most importantly, the internet applications run on end systems. They do not run in packet switches in the core network or in the network core. Applications do not run in routers, neither routers nor switches. They run on end systems. Now, here are some common misconceptions that people use to make about the internet. The first is that some people think that the internet is the cloud, and the answer is absolutely no. Because the cloud is a part of the internet mainly as a content provider network, not the internet. It's a part of the internet. Don't misunderstand this. The second is that people think that the internet is a resource that can run out or be limited. Let's make this clear. The internet is a connectivity, not some pre-produced product. The money that we pay for the internet bundles is for total amount of traffic you have exchanged with the network in a given amount of time. So that's the same for all ISPs and content provider network as well. They also pay this internet as we do, except Tier 1 ISPs, and we'll see this in details soon in ISPs courses. Yeah, it shall come soon in ISP courses. If this video helped you, you can hit that subscribe button so you can't miss the next courses. See you in the next video.